So we just reviewed that the solid of revolution using disk method is definite integral a to b of a of x. And as you know, a is the area of this circular object, the disk, pi r squared. But since r is changing with respect to x, we have to use the curve f of x, and the volume becomes the definite integral a to b pi f of x squared dx, and f and r are the same thing. So f of x squared and r squared are the same. Question says, find the volume of the solid generated by revolving the region bounded by y equals to square root of x and the lines y equals to 1 and x equals to 4 about a new line. It's not x-axis. It is y equals to 1. Okay, we are making it more interesting. So this is basically y equals to 1 and then y equals to square root of x. So if we try to rotate this object around the line y equals to 1, we are looking for the distance between the maximum y value and minimum y value. The maximum y value is located on the curve square root of x, and the minimum y value is located on y equals to 1. So the difference between these two, the delta y, is square root of x minus 1, and this is your radius. Now that we identified r, and we start rotating this object and get this 3D surface, you see that the cross section is just the disk. The radius is square root of x minus 1. So to calculate the volume is the definite integral 1 to 4 pi rx to the second power. So pay attention here. Y is equal to 1 and x is equal to 1. When you plug in 1 here, your x becomes 1, the intersection between these two. And then your x is equal to 4, which is this portion of your object. Now this is equal to the definite integral of pi r to the second, but r is nothing but square root of x minus 1 to the second. Then we take the integral with respect to x. Sometimes we have to switch variables because it makes taking the integral a little bit easier. But some other times we just leave it as it is. So r squared is again square root of x minus 1 to the second. And then this guy can be written as pi, the definite integral from 1 to 4 of square root of x minus 1 to the second in expanded form is x minus 2 times square root of x plus 1 dx. Again, pure algebra, everybody. If you have a minus b to the second, it is a squared minus 2ab plus b squared. A is square root of x and b is 1. So, as you can see, get square root of x to the second. Let me write down the detail for those of you who are interested in seeing this. Get square root of x to the second minus 2 times square root of x times 1 plus 1 squared, which is x minus 2 square root of x plus 1 dx. Using the power rule formula that you learned before, this becomes pi times x squared divided by 2 minus 2 times 2/3 x to power 3/2 plus x, and then x ranges between 1 to 4. First we plug in 4, then we plug in 1, do the subtraction, and the result is 7 pi over 6. So the volume of this object, which we rotated about this line, y equals to 1, has volume 7 pi over 6. So again, the most important part for you is to identify your cross-section and find the radius of this cross-section. And you can think about the radius as the distance between the maximum y value and the minimum y value.